Hello, my name is Tate Pottybaum, and I'll be speaking to you today about super resolution for mid-wave infrared imagery enhancement, or SUPREME, the technology that we've developed at Opto-Knowledge Systems under the NAVSEA topic, Improved Infrared Imaging with Variable Resolution Achieved via Post-Processing. Before going into the details of SUPREME, I'd like to tell you a little bit about Opto-Knowledge. We were founded in 1991 with a focus on building hyperspectral imagers. Our founder, Nahum Gatt, is still active with the company today. Over the past 30 years, Opto-Knowledge has been repeatedly recognized for excellence in research and development and in commercialization. This includes receiving the Army Quality Award for technology developed under an SPEIR program, as well as earning the Tibbets Award, which recognizes commercialization success based on SPEIR technology. We have a broad cross-section of government customers, including the Missile Defense Agency, the Navy, Air Force, Army, Intelligence Community, NASA, Department of Energy, and NOAA. We also have a broad range of commercial customers. Our current sales are about $12.5 million per year. A typical program at Opto-Knowledge involves externally funded research and development in support of U.S. government science and technology goals. We take concepts and develop them all the way through prototypes that prove their usefulness in the real world. We then typically license the technology developed to other companies for incorporation into their products or for production. An example of this is the VARIAP, Variable Aperture Cold Stop, which Opto-Knowledge first developed under an SPEIR and is now used in all third-generation FLIR systems. Our expertise at Opto-Knowledge is in multidisciplinary systems engineering, with an emphasis on EO/IR remote sensing. Opto-Knowledge has the capability to build complete systems or to contribute subsystems to larger projects. This includes modeling and simulation of the phenomenology to be observed, designing and building hardware and software to perform those observations, implementing algorithms to extract useful information from the raw data, and where appropriate, implementing real-time processing. Our projects cover the full EO/IR spectrum from UV through long wave, and we have built multispectral and hyperspectral imagers, spectrometers, and situational awareness sensors. In more recent years, our portfolio has expanded to include autonomous systems, deep learning, and machine vision. We also build mid-IR lasers and absorption spectroscopy instruments, as well as making and selling hollow core waveguides. Opto-Knowledge instruments have been deployed on the ground, in the air, at sea, and in space. For more information about our products and capabilities, please visit our website, www.optoknowledge.com. I'll turn now to the Navy challenge that motivated SUPREME. The Navy typically uses mid-wave IR imagers for two distinct purposes. The first is weapon system functions, things like target recognition, target identification, and aim point selection. These applications require high spatial resolution, lots of pixels on the target. The other type of applications are situational awareness, which inherently require a very wide field of view, such as 360 degrees or even a full hemisphere. These two different types of applications drive the optical design of an imaging system in opposite directions. Therefore, if you wanted to have a single conventional system that fulfilled both functions, it would require an extremely large focal plane array, something on the order of 16 million pixels, which would be very expensive. Another option would be to have two completely separate mid-wave IR imaging systems, one for each type of application, but this would require you to have two sets of focal plane arrays, two sets of optics, and two sets of cryogenic coolers. This is also a very expensive option. So, with existing technologies and approaches, fulfilling both weapon system and situational awareness functions has a high cost. In order to find a way to address both needs While lowering the cost, Opto-Knowledge developed the Super Resolution for Midwave IR Imagery Enhancement, or SPEIR technology. To address this challenge, what is needed is a way to enable one smaller, less expensive midwave IR system to meet the requirements of both targeting and situational awareness applications. Imagine designing a midwave IR system with optics and a focal plane array such that the raw imagery is suitable for situational awareness. If post-processing could then be applied to spatially enhance a selected region of interest within that raw image by a factor of 4 times or more in each direction, the resulting imagery would have sufficient resolution to support weapon system functions. Unfortunately, this requires a higher level of spatial enhancement than currently available solutions can achieve. In addition, most currently available super-resolution solutions were developed for use with visible imagery, which has very different characteristics than midwave IR imagery. Therefore, Opto-Knowledge has undertaken to develop, implement, and demonstrate a new super-resolution method specifically designed for midwave IR imagery and producing high levels of enhancement. In addition, this new method enables the super-resolution parameters to be tuned for individual imaging systems by taking into account system-specific attributes. That means that the same software can be used with multiple deployed systems. It is also worth noting that while the motivation here is to enhance situational awareness imagery, making it suitable for targeting, the method can also be applied to refine imagery from dedicated high-resolution systems, producing even higher quality imagery. Opto-Knowledge partnered with computer vision experts at Northwestern University to develop SPEIR. When development is complete, SPEIR will provide real-time variable resolution capability in regions of interest, and we are pursuing up to 10 times spatial enhancement. Here you can see a couple of examples of the results that have been achieved to date. The upper pair of images shows a general aviation aircraft on approach for landing. The top picture is the raw image, and the bottom image has been enhanced by a factor of 6x using SPEIR. Note that many small features are evident in the SPEIR image that cannot be resolved in the raw image. This includes the landing gear and the hotspot around the engine. It is also possible to distinguish the bright horizontal stabilizer from the dimmer vertical stabilizer. These are features that would be useful for target recognition or aim point selection. The lower image pair shows a cargo ship entering a port, with a buoy in the foreground at center and some lights in the background at the left. Again, the top picture is the raw image, and the bottom image has been enhanced by a factor of 6x using SPEIR. SPEIR not only sharpens the overall image, but also, as in the first example, reveals small features that are not evident in the raw imagery. This includes the small isolated hotspots near the smokestack and a deck level below the smokestack. These features were confirmed to be real by comparison to high-resolution truth imagery. They are not just artifacts of the method. So how does SPEIR work? The method operates by first locating and then enhancing edges within the image while maintaining the smoothness of the image away from the edges. Each edge is sharpened in the enhanced image by imposing an explicit mathematical representation, or prior, for midwave IR edges that is balanced or regularized against fidelity to the raw imagery. This formulation directly incorporates camera parameters such as the f-number and the undersampling ratio, and therefore can be tuned for individual imaging systems. Development of SPEIR is currently on track to be ready in time for transition to the Ship-Borne Passive EO/IR, or SPEIR program. In the first development milestone, just over a year ago, the SPEIR method implemented in a pipeline was applied to pre-recorded imagery representative of the SPECS system, which was a pathfinder for the situational awareness system in SPEIR. More recently, SPEIR achieved TRL5 with application of an improved algorithm and pipeline to pre-recorded imagery from a demonstration system imager. Later this calendar year, SPEIR will be incorporated into a demonstration system such that it is operating on a live video feed and will achieve TRL6. SPEIR offers many potential benefits for integration into MWIR systems. While SPEIR is a software method, its primary benefit is its impact on hardware by enabling the use of less expensive MWIR sensors to perform both targeting and situational awareness functions. SPEIR has an advantage for this application over other super resolution solutions because it was specifically designed for MWIR imagery. In addition to integration into new MWIR systems like SPEIR, there is also a market for SPEIR to be used to upgrade existing systems without requiring any changes to imaging hardware. In terms of SWaP-C, SPEIR benefits every point. By enabling the use of smaller FPAs, SPEIR can reduce size, reduce weight, reduce power, and reduce cost. This may also have a multiplier effect, as smaller, lighter sensors can use lower SWaP-C mounts, turrets, and gimbals. The current transition target for SPEIR is to be integrated into the core image processing capabilities of SPEIR. However, the initial operating capability for SPEIR is 4 to 5 years away, and SPEIR can transition to and benefit other Navy programs even sooner than that. Potential benefits exist in any application where midwave IR imagers are planned or are currently being used, both on Navy vessels and aircraft, as well as in other DoD branches. For new applications, SPEIR can enable lower SWaP-C sensors, and for existing applications, SPEIR can provide upgraded capability without requiring hardware changes. Some specific programs where we believe SPEIR would improve performance are periscope-mounted sensors such as the Safran Series 30, small SWaP-C sensors for UAS like the FLIR Neutrino, and airborne systems including the NGC Lightning Pod. Outside of the DoD, SPEIR again potentially provides benefit in any application where midwave IR imagers are used. Security applications in particular are transition targets, both for new programs or products and for upgrades. The path forward on all of these potential transition opportunities is two-pronged. OptoKnowledge needs the opportunity, through introductions and socialization, to present the benefits of SPEIR to decision makers at NAVSEA, NAVSEA, OpNav, and in other branches. This can help to create a pull from the warfighter side for the capabilities offered by SPEIR to be incorporated into programs. At the same time, OptoKnowledge is looking to partner with one or more primes to push SPEIR out to the warfighters, both through SPEIR and through other programs. SPEIR is not a standalone product, but it can enhance the capabilities of the tools we provide to the warfighters. Thank you for attending this presentation about SPEIR, Super Resolution for Midwave IR Image Enhancement. If you have questions, would like additional information, or would like to start a conversation, please contact us by phone or email using the information listed here, or stop by our virtual booth at this conference. If you stop by the virtual booth, please be sure to include your contact information in your message in case we're not able to immediately connect.